Hi folks, welcome back to the integrals review for Math 151. Alright, so in this video we're going to take a look at some definite integrals and also bring back some trig and some graph sketching. So let's take a look at example 6. This says, find the integral from 0 to pi of sine x minus cosine x dx. So what we're trying to do is find the area between these two curves, and we're going from 0 to pi. And so what we're going to do is we're going to find the integral of each piece, and we're going to plug in pi, we're going to plug in 0, and we're going to revisit that unit circle. All right, so the integral of sine x is negative cosine x, minus the integral of cosine x is sine x. Now I don't need a plus c because I have bounds. In fact, I have a bottom bound of 0 and a top bound of pi. So I'm going to plug in pi and I'm going to plug in 0. So let's plug in the pi first. Minus cosine pi minus sine pi. Okay, that is my plugging in the b, or we can say this is f of b, minus negative cosine of 0 minus sine of 0, and that is when we plug in our bottom bound, or our a. So we can call this f of a. All right, now we got to think back to our unit circle, okay? So a quick unit circle refresher. Cosine x on our unit circle is all of the x values at a certain angle, whereas sine x is all of the y values, okay? That is something that we definitely need to know. So let's sketch a quick unit circle here. All right, and let's locate the angles that we want. So pi, and pi has coordinates of -1, 0. And the other angle we're interested in is 0, and that has a coordinate of 1, 0. Okay? So now let's plug in our values. Negative cosine of pi. This means go to the angle pi, find the x value there, and make it negative. So negative 1. Minus sine of pi means go to the same angle and find the y value. So minus 0. Minus negative cosine of 0. So negative cosine of 0 means go to the angle 0, find the x value there, which is 1, and make it negative. Minus sine of 0 is the y value at that angle, so minus 0. All right, what does this simplify to? We get 1 plus 1, which gives us a total of 2. And so that area is 2. All right, if you don't know your unit circle, please start to work on that. It is something you will definitely need to know as we work through these problems in the whole semester, okay? All right, let's take a look at example number 7 here. So example number 7, we've got the area from 0 to pi. So we've got our a value, we've got our b value, and we want to plug that in to x and sine x after we take the integral. So to find the integral of x, I'm going to get 1/2 x squared, so that's just using my power rule, minus the integral of sine x is negative cosine x. I'm going to plug in pi over 2, and I'm going to plug in 0. All right, let's clean that up a little bit before we plug in our numbers. So we have 1/2 x squared plus cosine x, plugging in pi over 2, plugging in 0. All right, first number I'm going to plug in is the pi over 2. 1/2 pi over 2 squared plus cosine of pi over 2. So there's my b value, there's my b value, minus 1/2 times 0 squared plus cosine 0. And that is my bottom bound, or my a value. All right, so some parts of this will need our unit circle, some parts we won't. Pi squared over 2 times 4 is 8, so pi squared over 8, plus cosine of pi over 2. Well, let's sketch a quick unit circle. Pi over 2 is right here, and the coordinates for that are 0, 1. So if I want cosine of pi over 2, I need to find the x value at that angle, which will be 0. Minus 1/2 times 0 squared is 0, plus, let's go back to 0 degrees, right? So at 0 degrees, the coordinates are 1, 0. So since it's cosine, I want the x value, and so I'm going to plug in a 1 instead of cosine 0. All right, what does this clean up to? We get pi squared over 8 minus 1, and that represents our area of that part of the curve. All right, folks, let's keep going. All right, so one of the last things you learned about in Math 150 or Calc 1 is something called U substitution. In fact, it was one of the only methods you learned on how to find an integral without using basics like a power rule or just doing the opposite of a derivative, okay? So we're going to go ahead and practice a few cases of U substitution, all right? This is going to be something where we're going to see these questions a lot, and it's going to be something we're just kind of expected to know how to do in the middle of a problem, okay? So we're going to see U substitution in the middle of a problem using other techniques, and it's really important that we know how to recognize that. All right, so let's start with number 8. So number 8 says the integral of sine x times cosine x. So one of the things that is really good to know is that when you are looking to do U substitution, it is basically the equivalent of chain rule. Okay, so chain rule for derivatives, but it's like chain rule for integrals. Okay, so it's when you took a derivative and you used chain rule, how do you go back and find out where it came from? And one of the things that we're really going to focus on looking for, we're going to look for a function and at least part of its derivative. So we want to see these parts in the thing we're integrating, or we call that the integrand. Okay, so we're looking for a function and at least part of its derivative in the integrand. So when we go back to example number 8, I see sine and I see cosine. And I notice that sine, okay, if I think about the derivative of sine, well, I get cosine, okay? So what we're going to do then is we're going to set our u, equal to sine x. Now from here, we're going to take the derivative of both sides. So we get du dx equals cosine x. Now we have to segregate all of the x's on one side and all of the u's on the other side. So I'm going to take the dx and I'm going to multiply it to the other side. That's going to give me du equals cosine x dx. Now what that means in our problem is this. Everywhere we see a sine x, okay, everywhere we see the sine x, we can replace it with a u. So if I start my u substitution, get the integral of u, because the sine x became a u. Now what else can I substitute? Everywhere I see a cosine x dx, okay, it has to be the whole thing. I have to have the dx there. Everywhere I see a cosine x dx, I can replace that with du. That means the whole ending part just becomes du. All right? So a problem that looked really complicated, the integral of sine x cosine x, when we use u sub, just becomes the integral of u du. And so here we can just use our power rule. So 1/2 u to the 2 plus c, because I don't have any bounds. Now, we don't want to leave our answer like this. We want to make sure that we put back in the letter we started with. So everywhere we see the u, we're going to go ahead and put back in the sine x. So that's going to give us 1/2 sine x squared plus c, or we more traditionally write that as 1/2 sine squared x plus c. Right? So a quick u sub problem. Let's go ahead and do one more. So example number 9. Okay? Now when we're choosing our u, it's really important that we choose it well. We want to choose it in a way that helps us, okay? So let's say that we didn't know and that we were going to do it exactly like we did the last problem, and we wanted to say, well, last time u was sine x, so let me do that again. That would mean du over dx equals cosine x, or du equals cosine x dx. Okay? Now remember what we're looking for. Let's go back to the previous problem real quick. We're looking to substitute the whole thing. Okay? Now this dx is in the numerator. It's not in the denominator. But when I look at this, I can't match cosine x dx because the cosine is on the bottom and the dx is on the top. So when you get to a situation like that, just try doing it the other way. So maybe you let u equals cosine x, and then du dx would equal negative sine x, or du equals negative sine x dx. All right, now can we match everything here? We've got our cosine x is u, so on the bottom I'll have u cubed. And then I have sine x dx, sine x dx. So all I'm going to do is divide this minus sign to the other side, so I get negative du is what I can put in everywhere I see sine x dx. Okay? So let's substitute.